This is our first video on cost by parts. So it says, a prison wants to build an exercise yard as shown below. The outside walls of the yard are to be built using fencing that costs $50 per meter. The inside partitions of the yard are to be built using fencing that costs $25 per meter. They have $12,000 to spend on the fencing. So first part, it says determine the restrictions on the length. So we have to choose one direction to be length and one to be width. It really doesn't matter, but I'm going to pick this to be my length and this to be my width. Simply because that was longer and this was shorter. But you could do it the other way around. Okay, it didn't say anything about the individual cells needing to be a certain size. So I am going to assume that the smallest possible length is 0. Right? That it would basically just be this was absolutely nothing and it's all width, no length. And then my largest length would be if it was all length, no width. So we basically spent our entire budget just on this one piece of fencing. Now, I know that we have $12,000 to spend, and this is outside, so it costs $50 for that piece of fencing. So I would take the $12,000 and divide it by $50 to get that the most I could have is 240 meters, right? If we spent all the money we had on this one piece, that would be 240 meters long. So that means my length has to be somewhere in between 0 and 240. Now, it doesn't really make a lot of sense for it to be 0 or 240, but those are kind of the upper and lower bounds of what our length can be. Okay, second question asks us to do it again, but to do it with width this time. So this time, my smallest width, well, it's the same thing as the length. The shortest my width could be is 0. The largest is a little trickier. And the reason why it's a little trickier is the largest it could be is if we spent our entire $12,000 budget just on width pieces and didn't spend any of it on length. But the width pieces aren't all the same price, right? The 2 outside pieces cost $50 each, and the 2 inside pieces are $25 per meter. So I'm going to try to make a little equation and then see if I can solve. I have 2 pieces, so I have 2 widths that cost $50 per meter. So I'm going to find its cost by multiplying the length by the price. And then I have 2 pieces that cost $25 per meter. So I'm going to multiply how much I have by the price that we're buying it at. And that together should equal $12,000. All right, 2W times 50 is 100W. And then 2 times 25 is 50W equals 12,000. There's a 1 there, you just can't see it. And then that would give me 150W if I collect like terms equals 12,000. So I'm going to divide 12,000 by 150 and I get 80. So the longest that piece could be, if I spent all of my money on the width pieces, would be 80. So that means my width has to be between 0 and 80. Okay, so we're actually going to try the question. It says, determine the maximum total area that they can enclose and what are the dimensions. So it is asking me for area, so I'm going to start there. Area of a rectangle, which is what this is length times width. Do I know what the area is? No. Do I know what the length is? No. Do I know what the width is? No. So I need another equation, maybe with some other information. The only other thing they told me was that they have a budget of $12,000 to spend. So I need to try to take that and see if I can create an equation about the cost. Okay, the cost is going to come from the 1 length piece and the 4 width pieces, but they're all different prices. The outside parts are $50 per meter and the inside parts are $25 per meter. So I'm going to start with just a little word equation. So we're going to do the cost of the length plus the cost of all my width pieces. Okay, so I know that I have $12,000 to spend. That's my cost. And then to find the cost of the length, I would take however many meters we're using and multiply it by the cost per meter, which is 50. So I'm going to say the cost of the length is $50 times the number of meters that we use, or the length. And then the width is trickier because there's 2 parts, right? I have 2 parts that cost $50. So I'm going to have 50 times 2 widths, because I have 2 widths that cost $50 each. And then I have 2 widths that cost $25 each. So I'm going to do 25 times 2W, right? I'm multiplying how long times the price. All right, from here I'm just going to tidy this up a little. So I have 12,000 equals 50L plus 100W plus 50W. I've got some like terms here. So I have 12,000 equals 50L plus 150W. Okay, from here we have a choice. We can rearrange and try to isolate L. We can rearrange and try to isolate W. If I rearrange and I rearrange for L, then when I move this over, I'm going to divide by 50, and 150 does divide nicely by 50. If I rearrange for W, when I do that, I'm going to end up dividing everything by 150, and I'm going to have fractions. So I think I would rather rearrange for the one that has the smaller coefficient. So I am going to do the length. So I'm going to start by subtracting 150W. And that equals 50L. And then I would divide everything by 50. You could just do one big fraction on the other side, but it'll work out better for us if we do them individually. All right, so I get 240, take away 3W equals L. So then what we're going to do is in our equation here, everywhere I see an L, I'm going to put in 240 minus 3W. So this is going to give me that my area is 240 minus 3W times W. I'm going to multiply that out because it's easier to take the derivative with it expanded. So that is 240W minus 3W squared. And that is the equation that I am using for area. From here, to find the maximum total area, we are going to take our derivative. We are going to set it equal to 0 and solve. We also are going to use the domain that matches the letter that we have. So if we're doing width, we're going to use the domain that matches that. So I'm doing 0 is less than or equal to W is less than or equal to 80. Okay, let's find our derivative. You can do A prime or dA by dW. Derivative of 240W is 240. The derivative of negative 3W squared is negative 6W. We are going to set that equal to 0 and solve. I'm going to bring that 6W to this side to make it positive. And then divide both sides by 6, and I get 30. Is 30 within my domain? Yes, it is between 0 and 80. So we are going to calculate the area for 0, for 80, for 30, and then try to see which one we think is the largest. All right, so my area at 0 is 240 times 0 minus 3 times 0 squared, which is just 0. My area at 80 is 240 times 80 minus 3 times 80 squared. So 240 times 80 minus 3 times 80 squared is also 0, which makes sense because we got that by letting the length be 0. And then last but not least, the 30. My area at 30 is 240 times 30 minus 3 times 30 squared. I got $4,500. So the maximum total area is going to be 4,500, and then it also wants to know the dimensions. So I know the width is 30, and then to find the length, I am going to go back to the equation where we rearranged for length and use that. So I know that my width is 30. And then my length is 240 minus 3 times 30. Should be what, 150 maybe? Yep, 150. So to finish it off, our maximum area is 4,500 meters squared when the width is 30 meters and the length is 150. The maximum area is 4,500 meters squared when the width is 30 meters and the length is 150 meters. Okay, I will see you in the next video for the next question.